VLPSos here. This is a video lesson for Python programming while loops. These videos are made with the intention that they could be paused so that you can practice. Very often we want a process or program to run continuously. For that we have looping. The first loop that we're going to introduce is called a while loop. And we need to set a Boolean variable equal to true to begin this example. Use the keyword while and then a condition. Notice the double equals is what we use for a condition to ask, is the value of playing equal to true? If it is, then we'll do the code block under this keyword while. And we'll continue to run this code block over and over and over again until that condition, playing equals true, evaluates false. It will evaluate true because we set the value of playing to be equal to true, which means the condition is true, and the code block that we'll write that will continue to go or continue to run will be this print statement. If I ran my program now, I can see that it continually prints that line playing, and it will not stop. So I need to force it to stop with a Control-C. I can get this program to run and break out of the while loop so that it doesn't continue to play by reassigning the value of playing to be false. This has been added to the code block under the keyword while. So this is going to begin because the value of playing is true, which means this condition is true, and it will run this code block. It'll print this statement, but then it will get to reassign the value of playing. So the next time that it checks to see if it's going to run this code block in a loop, it will evaluate false because the value of playing has been changed. If the value of playing is false and this condition is false, then it will not run the code block. In this case, we ought to see it run once, but not loop. Let's make a note of that. While is a keyword that begins a loop. The loop also has a condition. The code block will run as long as the condition evaluates true. The above code will run indefinitely if there is no change to the condition. And we added a change after we saw it run continuously. If you need to use the keyboard, Control-C to force an infinite loop to break. Or I should say you may need to use the keyboard Control-C to force an infinite loop to break, which is what I pressed when I got into the infinite loop before I added this line to the code. Let's see the while keyword used to start a loop in another kind of different example. This time I'm assigning count equals 0 as an initial value for a new variable count, and we'll start a while loop on the condition that count is less than 10. This is a mathematical condition. It will evaluate true as long as count is less than 10, and if count is set to 0, it will be at least once. The code block that I will write in this loop is a print statement. Running in a loop. And then I'll close that string and include in the print statement count so that it shows us the value of count. I'm also in this code block going to increase the value of count by 1. And you'll notice I used a shorthand way of saying count is reassigned to be equal to itself plus 1. Plus equals is the same thing as saying count plus 1 with a reassignment. And then not inside the code block, this print line is not indented in the code block under the while loop. So we'll have to wait for the while loop to finish, if it ever does, to then get to this line, which prints out of the loop and provides a space. If we run this code, we can see that our first loop still reports playing just once. We see this print line and the value of count added. Every time that it printed this line, the value of count has changed. We see the last value of count is 9, and then this line out of the loop. So if we take a look at our code again and the output, we can get a better understanding of what's going on. The value of count was 0. We started the loop because this condition was true. We printed this line, including the value of count, which showed us that it was 0. And then we reassigned count to be equal to itself plus 1. And then the code block of the while loop ended, which means that it goes back up to the top to check to see if the condition is true. And if it is, it will run the code block again. The value of count was increased to 1 here, so when this condition was checked, 1 is still less than 10. So it did run the code block again. It reported the new value of count and then added 1 to it. That repeated until adding 1 to count made the value of count 10. And once it was, it went still back up to this condition to check, is 10 less than 10? And finally count was high enough to make this condition false. So it did not run the code block. It skipped over the code block of the while loop and continued on with the rest of the program, which was this print statement. Notice that we saw the last value of count to be 9, which is the last value that count was allowed to have in the code block that was run in the loop. There are various ways to control a loop. So in the first example, we controlled it with a Boolean value that was playing, and in the second, we controlled it with an inequality and an integer value that was count. Let's provide another example. I'm going to reassign playing to be true, and I'm going to begin a while loop. While playing is equal to true, we will have input from the user, and we'll call it guess, and then we will check guess. We'll take care of if the user uses capitals by lowering everything, and we'll provide a list that we're checking to see if guess is in. If the guess or the user input is in that list, which has 2 elements, then we will print a report clever, but we will also reassign playing to be false. And then we'll have a condition, or not a condition, but a code block else if the first condition with the keyword if did not evaluate to be true. And we will report to the user with a print. And then outside of the code block of the loop, we will print out of the loop to be sure that this loop has ended when it does. We ought to be able to anticipate what to expect when we run it. Let's see. We get to the third example where it says guess my name. And if I put something in that was not in the list, then I see that it gives the else code block. Ha ha ha, you will never figure it out, or my name isn't. And we can continue to guess, and we'll continue to be in the loop. This loop continues to run, which includes repeating the lines of getting input from the user and then reacting to that input until the user guesses the name. There are 2 in the list, and when it does, it reports clever and then shows us that we were out of the loop by running this line, which is the first after the code block of the while loop. So this loop got terminated based on user input. And we'll make a note, the above loop required playing to be reassigned. We could also use the keyword break to force the loop to end immediately. For example, another loop, we'll assign go to be equal to true and start a loop with the keyword while go is equal to true. Then do this code. You will see this line, and then the word break, which is a keyword, which is why it's colored, and then another print statement. And a print line out for a 4th time. This is a loop intended to show you how that keyword break works. Let's see how it runs. Guess my name. And we can see that the output after the guessing the name was you will see this line as it anticipated, and then it said out for a 4th time. Notice that it didn't print this line, and we did not get to this line as well because the keyword break appeared before those lines. The keyword break automatically forced us out of the loop that the break was in. So as soon as, if we were in the while loop, as soon as we got to this break statement, then we didn't do any of the rest of the code within the code block of the loop. We immediately escaped or broke the loop and proceeded then to the line outside of it. Now, we can see another way to see that go was not reassigned is we could run this code, and if it runs in idle, we could ask idle for the value of go. The program that was run is still in memory of idle, so the variables that were defined we can see the values by asking, and the value of go, if we typed it in, showed it to be true. So this loop did not break because go was reassigned. We never got to that line. Go is still true, the original value that we assigned it. The loop above could have ended with the reassignment, but the keyword break forced the immediate termination of the loop. And though you know that break exists, and break is sometimes necessary to write code with the right kind of flow, try to control loops without using break. It's too easy and leads beginning programmers to develop bad habits. If you know that break can break out of a loop, then a beginning programmer tends to overuse break, and then instead of controlling loops with math or booleans, and it tends to lead to code that becomes difficult and unwieldy when programs become more sophisticated. So try not to use break unless it's needed. Now you write a simple program that outputs the square, and we can square a number with the double star. A program that writes the outputs of the square of the numbers from -6 to 6 by using a while loop. So output that math using a while loop. And then write a second loop that does not terminate, and practice using Control-C while it's running to force it to break. So have the experience of using Control-C to get yourself out of a loop that's running.